Okay, so this problem starts to become or to look complicated because you're given very little information, but it's very practical. If you are trying to use Archimedes' principle, the only information you can get is the weight before you put in the air and the weight in the water. Okay, so those are what are given. This is what it looks like. You weigh it in the air, you get that. You weigh it in the water, you get that. There's a loss, right? And again, just to remind everyone, there's an Fg, the weight going down of the metal, and there is an Fb of the water pushing up. But this is not equal, right? Because obviously it's the Fg is still bigger, right? How do you get the Fb? Well, it's called the loss of weight. So if you get the weight in the air and you subtract the weight when it's already in the water, that loss of weight, that is going to be your buoyant force. Okay? The other thing that you get from this problem is that as long as the ball is completely immersed, then the volume of the metal is equal to the volume of the water. Okay, in this problem, what you're asked to solve for is the volume of the metal. Okay, so I wrote it here, that the buoyant force is the loss of weight, which is the weight in air minus the weight in water. Now this is our starting point. This is what we're going to solve for, so write that down. We're looking for the density of the metal. And we know we have to get the mass of the metal divided by the volume of the metal. And we are not given any of these, so we have to compute for both. So we start with the weight of the metal is the mass of the metal times G. This is what we're looking for. So we divide that there, and that's what we get. So here is the mass of the metal, right? So we write that. The weight of the metal, which is given, divided by G. Okay? The volume of the metal we can get from buoyancy, because we have the buoyant force is equal to density of water times G times the volume of the water. Right? By the way, it's equal to the volume of the metal. So if we're solving for the volume of the metal here, we have to divide both of these by rho of water and G. Okay? So the volume of the metal is now going to be equal to FB divided by G times volume of the what is this, of the metal. And it's up to you. You can actually solve for these individually or just put that whole thing instead of that. So you write FB divided by G, and this is times the volume of the no, this is density of water. Okay, so right here, density of water. Notice you can cancel G. And so to get this answer, the density of the metal is actually Fg over Fb times, this is the denominator, so it goes up, the density of water. And this is very useful later when we're doing our experiments because it's already in the right format. And so you substitute the values, That is that one up there, 0.096 newtons divided by FB is this one here. Remember, it's the loss of weight, newtons, and then times the density of water is 1,000 kilograms per meter cube. Okay? And the answer is going to be, yikes, I'm going to write it here. Density of the metal is 3.77 kilograms per meter cube. Please verify this value from these numbers. Hopefully that's correct. Okay?